a couple times. It's about to go through.
Oh no.
All right, welcome.
Hi.
We left off last time drilling into 1-inch thick steel plate, and we're continuing to drill into 1-inch thick steel plate. But we figured, beginning of each episode, we're gonna do an opening of what we've received since then.
I already opened it.
Yeah, a lot of it's already open, but hey, boom, slip ring. This is by far the most expensive part that we ordered. It takes the electrical power from here, that base housing, and it transfers it up to here, which will be rotating. So the base can sit still, and the center can rotate, and these top wires can rotate. These wires will go to the arm that's rotating. These will sit still. That way our wires don't get all mixed up, and we can get power to our rotating arm. This is $150. It's not a lot from like machining terms, but it's a lot for the dusty garage. So that's like a significant portion of our budget in this one part.
And drill bits, because we gotta use a lot of drill bits.
Stack of them because we're eating through our drill bits. But
Saving money with these.
yeah, as long as we don't break more than 7 of them, we still save money versus getting the 2-inch annular bit. And then we also got a
broken one.
Oh no. We also got a 1.5-inch hole saw. So the center plate we will cut with a 1.5-inch hole saw so that the shaft can go through that. But that will be smaller than the 2-inch hole we cut in the top and bottom plates that we press the bearings into. That way the bearings can sit on top of that center plate and the shaft can go through. So we're gonna try cutting some holes with this as well.
Okay, more drilling.
And more drilling. And then what else we got?
The arm.
So we're gonna mount the hub to our arm today. So we're gonna take some 80/20 from the old CNC that I built, and we're going to install that hub onto it today, as well as continue drilling for eternity.
Go.
Cool, let's get it. Yeah, so let's measure center and then drill. Probably need to get some bolts that are long enough to go through, and then nuts to nut them on the other side. But then I have to
Go through the entire thing.
Yeah, I think so.
That's a long nut. Bolt nut.
We line these up just right. We can use the T-slots temporarily. That's not gonna be very strong. But we can do it short term and then drill all the way through and then bolt and nut.
$35. 17 in the.
$53. It's like 17 does not. I'm like, your math is right, but man, it does not look very soon.
Oh, look.
Half of 35 is 17 and a half. But I'm like,
I know I can do math in my head.
Right.
Damn it.
There's no way that's halfway.
53.
53.
53. 26 and a half. That looks a lot better right there. I think that'll work. Goddamn morons.
I'm like 35, and I'm sitting there trying to figure it out.
At least you looked at it and you're like, yeah, 35.
Yeah,
like,
when you said 35, I'm like, yeah, 35. And then I'm like, wait, this doesn't make any sense. Ah, shit. I'm like, as I saw 35, I'm like, how'd it go back down? Because I saw 42, and I'm like, wait, it went back down. My brain is so broken. Dude, oh my God.
It's all the fumes that came from that steel.
I think it's the kids that are our children. They're taking our life force.
I only have to count to 10 most of the time, but I don't. Okay. How
it's
do
the
you
small
want
holes.
it to? You don't care how the key lines up or anything?
Nope,
there?
that don't matter. 26 and a half.
26 and a half.
There's, that's pretty close, and we can shift it some because these will slide in here if we loosen them.
I like pretty spot on whenever I did it.
Pretty solid. All right, I'm not gonna tighten them very much because this is like, it's going into some pretty soft metal. And then all these big holes, these 4 here, I say we drill straight through on those.
Okay.
And then get big bolts and go all the way through, and then that'll be like what really holds it because these will shear. I mean, they are carriage bolts, so we could just drill the hole straight through and then hammer this in, and it'll deform the metal, and it'll hold it in place. And it's pretty centered, and it doesn't have to be perfectly centered because we're gonna chop off the ends anyway. Yeah. Unless we decide to keep it this long, and if we decide to keep it this long, we'll have to adjust our RPMs because we're measuring it from the center of the shaft 2 feet over. Going 700 RPMs will be 100 miles an hour. So that's what we're designing our motor to top out at so that we could throw 100.
100?
If we leave it longer, then 700 RPMs will be faster at the center of the disc. So. Progress!
Get it?
Yep.
Yeah.
Yeah.
Nice.
I'm probably just gonna use the footage of just like a little bit of me drilling.
Yeah, right. Not all 5 minutes of it.
And not all the janky like. All right, we just drilled our holes through for our hub to our arm, and we're gonna finish putting the bolts through. They're carriage bolts. We didn't square off the end of the hole, but it's aluminum, it's soft, so we're just gonna hammer that square into there, and then it's not gonna move, and then we'll put a washer and a nut on the other side. Yep. Just line this up how we want it, the square, and then go to town. There we go. Other side. Washer. Nut. We'll actually come back and get lock washers. I don't have any lock washers on me right this second, but we'll get lock washers so these don't move. Yeah. And then, you know, just turn it down a little bit. There we go. One more, and then we are all done. Ain't going nowhere.
Nowhere, bone saw.
All right. Shaft will end up going there. But there's a little keyway, so we'll need to get a key so that we can press that key in there, and this won't rotate, but that'll go there. All right, so we got some set screws to go in, and we actually do have a key. I went ahead and put in the lock washers, just stuck them between the nut and the flat washer, just keep them coming loose. We do have a little key, so that'll go in this slot here, and then also with the slot in the shaft. And that'll keep that shaft from spinning inside here. Then these set screws are just for funsies, really, after that key's in there, but I guess they help as well. You could drill little holes in the shaft and have the set screw go in and help even more, but that key is gonna be enough. Key's gonna be enough. All right. Let's start drilling. I get breaking through noise, or
I'm waiting for it to like hesitate like a couple times. It's about to go through. Yeah, like that.
woo, baby! That's what I'm talking about. That is hot. Yeah.
Crazy.
Yeah, it get thin enough that it just broke, pushed it through.
Right.
Well, that cut's not pretty, but it's
there.
It's there. Yeah, we'll definitely need to like do some sanding on it. All right, we got it.
One done.
So got most of the teeth still there. That one's gone, but whole saw made it. Not the cleanest cut, but it made it. Only lost one tooth, but we got some spares for the next cut. We only have to do 2 holes, so we would have bought a nicer saw. So inside, pretty rough cut. We're gonna sand it some, and then this bearing doesn't quite fit, which is what we were hoping for. A little bit of a press fit. After we sand it some and cool down the bearing and heat up the housing, we should be able to press it in. So that's what we're gonna try to do. A little better? Working? Maybe?
No,
Not really?
not really. Oh yeah.
Much better?
Oh yeah. What was I thinking? There we go. Well, good deal. Progress.
Okay, so
Progress of the day.
Tyler sanded it down nice and good, and it took a little off. So I think we're gonna be able to just press this in without having to heat it up, cool it down, get all crazy with it, and it's gonna be snug, which is perfect. We'll have to see if these bearings are even like close to the right size.
It'd be fun if that just like slid in like butter.
That'd be bad. Good?
Oh, damn. How's your foot? You good?
Yeah. Far enough out of the way. Yeah. It's pretty close. I think that's pretty good. Now, how does it spin?
Spins fine.
Spins better? Nice, okay. This time I went ahead and drilled 4 relief holes for debris, metal chunks to fall out, because one was not enough, kept clogging up, and hopefully this will help the hole saw cut quicker. We'll see.
Boom, baby!
Good job, old drill press. Insanely old drill press survived. Oh yeah.
Butter.
Pressing that bearing in nicely.
Like really thick butter that I have to put all my force into.
Maybe tap the top a little. Pretty good. Nice. Bearing out the freezer. You wanna stick that in there?
So she said.
Just the outside housing. Well, you can just try to set the whole thing. Oh yeah, make sure that this has a direction. Yep, that way. It's gotta go that way. Perfect. Yeah, it has a smaller OD than the other one, so it should just go right in.
So she said.
There you go. Okay, now okay. Yeah, look at that. That's
Yeah, right. One finger. Got it started.
you know how much it takes to get this thing started.
Nothing. Takes nothing.
It's gonna take nothing. Okay.
Nothing. See? 0. I fart stronger than that.
It takes basically nothing. I don't.
There's literally not a fish to catch that.
If I measure from closer, because like there's a lot of mechanical leverage from way out here.
Right.
Here. All right. You want to watch this thing? Yeah. It completely stopped. There's a little more.
Yeah, I saw 7.
So we end up measuring the arm 3 inches from the center of rotation of the shaft. And our fish scale told us that it took 0.06 kilograms of force to get it started. Now we can use those numbers to get our starting torque. What we're gonna do is go ahead and round that 0.6 up to 0.1 kilograms just to give us a little bit of a safety factor there. And then we're gonna convert that 0.1 kilograms to 0.22 pounds. We're gonna convert our 3 inches to 0.25 feet so we can get foot pounds. We're gonna plug this into our power formula here, which is gonna give us horsepower. So for our formula here, we know we want 700 RPMs and we can calculate our torque 0.25 feet times 0.22 pounds. We'll multiply those together and divide them by the constant 5,252. That gives us a power of 0.0073 horsepower, which is approximately 5.4 watts. We're gonna go ahead and add another safety factor here. Just double this up to 0.015 horsepower, or about, I would say 10.9 watts. So not a lot. Based on that, it really opens up our options for motors. We need a motor that is at least 10.9 watts, and ultimately, we want it to be able to spin the arm at 700 RPMs. We don't want the motor to be rated for exactly 700 RPMs because RPMs are listed without a load. So what we're gonna do is we're gonna find a motor that is in budget, it's available, and is at least 10.9 watts. And then we're gonna get different size pulleys to adjust that motor's RPMs to match the desired drive shaft RPMs, maxing out at 700. So we found this motor here. It's a 30 watt motor, it's available, it's within budget, and it's about the right physical size to be easily mounted to the side of our launcher housing. So now that we have the motor chosen, we have to get the pulleys in order to adjust this motor's RPMs down to around 700. The rated RPMs on this motor, when you're feeding it 24 volts, is 7,000 RPMs. That is 7,000 without a load. So we're going to estimate the motor can do about 5,000 RPMs with the load that we're gonna put on it. So we need to change this 5,000 RPMs down to 700. We're gonna use this online pulley calculator to help us do the math. So here we can pick the size of the pulleys and it'll tell us what the RPMs will be. So the shaft on our motor is 8 millimeters. So let's see which pulleys are available with an 8 millimeter bore. We found one here that has an outside diameter of 5/8. So we know the RPMs of our 5/8 pulley will be 5,000. From there, we can use the calculator to help us find what size the bigger drive shaft pulley needs to be in order to change that 5,000 down to 700. So let's go ahead and put 5 inches into the calculator. So 5 inches turns the 5,000 RPMs into 625 RPMs. It's a little low, so let's try a slightly smaller pulley. Let's go with a 4-inch pulley. Aha, that's better. With a 4-inch pulley, we're changing the 5,000 RPMs into 781 RPMs. It's close enough. Now we need to look and see if there's any 4-inch pulleys available. Only one I can find available has a bore of 24 millimeters. Now, our shaft is 1 inch, which is 25.2 millimeters. But what we can do is we can drill out the bore a little bit, hammer it on, make it fit. So that's how we chose our motor. That's how we chose our pulleys. We're just gonna get a belt that matches the pulleys, 6 millimeter round belt, and there we go. We'll go ahead and order all of that, and next time we'll start installing it. We're getting to the fun part. We're about to get some parts moving. Hey, we appreciate you watching, and we'll catch you next time in the Dusty Garage.
Possible that impact driver will strip it out super quick.
Hello, Zoe. How are you? She's like, I ain't dead.
So pretty good.